So hello everyone, welcome back to my YouTube channel. Today we'll be continuing our chapter that is sets. So this is a part 3 of the chapter. In part 1 and part 2, we have discussed how do we represent a set and what are the types of set. We have solved practice set 1.1 and 1.2 also. If you haven't watched the first two parts, do watch it. The link is in description. Now the first two parts were basic concepts of set. Now from this part, we will study the chapter in depth. So the first thing which we are going to study today is subset. Now, what is a subset? Let us understand. If A and B are two given sets and every element of set B is also an element of set A, then we say that B is a subset of A, which is symbolically written as like this. So to represent a subset, we have the symbol. We have a symbol which is like this. So as we have a symbol for belongs to, not belongs to, equal to, not equal to, similarly, we have a symbol to represent a subset. And it is read as B is a subset of A or B subset A. Let us take a simple example. Now my set A is 1, 2, 3, 4, and 5. So these are my 5 elements in set A. And my set B, it has elements 1, 4, and 5. These are my 3 elements in set B. Now, if you observe here, in set B, there are 3 elements, 1, 4, and 5. These 3 elements are also there in set A, 1, 4, and 5. Every element of set B means all these 3 elements is also an element of set A. They are also element of set A, right? Then we can say B is a subset of A. So here we can write B is subset of A. If every element of set B is present in set A, then we say B is a subset of A. Similarly, if every element of A is in B, then we say A is a subset of B. Okay, I hope you understood this. Let us see some examples. The set Q of rational numbers is a subset of set R of real numbers. And thus we can write Q is a subset of R. Right? In rational numbers, we include real numbers. So we can say that every real number is a rational number. So Q is a subset of real number. Similarly, we can say natural numbers are also subset of real numbers because every element present in natural number set is also a real number. Integers is also subset of real number. Whole number is also a subset of real number. Right? Also, we can say natural number is also subset of whole number. Because in whole number, we have 0 and rest other things are natural number. So every element from natural number is present in whole numbers. So natural number, set of natural number is a subset of whole numbers. Let us see next example. If A is a set of all divisors of 56 and B is the set of all prime divisors, then see in set A we have included all the divisors. In set B we have included only prime divisors. So what will be the subset? B will be the subset of A because every element of B will be present in A. Because in B we have only included the prime numbers, prime divisors. And in set A we have included all the divisors which are there of 56. So B is a subset of A. Next, let A is equal to 1, 3, and 5. B is equal to odd natural number less than 6. Now elements present in A are 1, 3, and 5. And elements present in B, odd natural number less than 6. Odd natural number means 1, 2 is even, 3, 4 is even, 5. And it is told less than 6. So we'll stop here. So my elements in B are 1 and 3 and 5. So you can see set A and set B, both are the same. Every element of set is present in B, yes. Every element of set B is present in A, yes. So in both the ways you can write. You can write A is a subset of B also. You can write B is a subset of B also. And this is a condition for equal sets. So equal set means A is subset of B, B is subset of A. If this is the condition, then we say the sets are equal. Let A is equal to AEIOU and B is equal to ABCD. Now here you can see every element of A is not present in B. Every element of B is not present in A. So neither A is subset of B nor B is subset of A. So then A is not a subset of B, also B is not a subset of A. So I hope you understood the concept of subset. Let us learn some properties related to subset. Every set is a subset of itself. That is, A is subset of A, right? For example, I have given a set A and elements in set are 1, 2 and 3. So same set A, again the elements will be 1, 2 and 3. So both set will be subset of each other. So I can say every set is a subset of itself. Empty set is a subset of every set. That is, phi is subset of A. Now what is empty set? Empty set or null set, it is a set in which there are no elements. So there are no elements. So that set is a subset of every set. Because when we say that the two sets are not a subset of each other, if the every element present in one set is not in other set, then we say that the both elements are not a subset of each other. But in empty set, we don't have any element. So we don't have any element to compare with others. So that's why empty set is a subset of every set. You take any set, empty set will be the subset of. Next, if A is equal to B, then A is a subset of B, also B is a subset of A. And we can do the reverse also. If A is a subset of B and B is a subset of A, then both are equal. As we have seen in the previous example here. Here, third example, right? Okay, I hope you understood the properties of subset and also what is a concept of subset. Now let us move to the second concept of today's, that is universal set. What is universal set? Usually in a particular context, we have to deal with elements and subsets of basic set which is relevant to the particular context. For example, while studying the system of numbers, we are interested in a set of natural numbers and its subsets such as set of prime numbers, set of all even numbers, and so forth. This basic set is called as the universal set. Let us learn it more in more detail. The universal set is usually denoted by capital U and all its subset by letters A, B, C, and so on. For example, for the set of all integers, the universal set can be the set of rational numbers, or for that matter, the set of real numbers. Okay, what are the set of integers? They are subset for rational numbers, real numbers. Set of integers is a subset of rational numbers and real numbers. So we can consider universal set as a rational number. We can consider set of rational numbers or the set of real numbers as a universal set for the set of integers. Then, for another example, in human population studies, a universal set consists of people in the world. So when we study the population, human population, so what is a universal set? All the people living in the world, these are my universal set. A cricket team of 15 students is to be selected from a school. So we want only 15 students. Here, all the students from school who play cricket is a universal set. We want to select 15 students, but there are more than 15 students who knows to play cricket. And from that students, we have to select 15 students. So that students become a universal set and these 15 students will become the subset. So a team of 15 cricket players is a subset of that universal set. Okay. So I hope you got the what is universal set. Let us now learn the third topic, that is complement of a set. Suppose U is a universal set. If B is a subset of U, then the set of all elements in U which are not in set B is called complement of B. Now, for example, this is my universal set. My universal set is 1, 2, 3, 4. This is my universal set. My set B. My set B is 1, 2. Okay. Now from this, I can say that B is a subset of U because every element of set B is present in U. So B is a subset of universal set. Then The elements which are not in set B is called a complement of B. Complement of B. We denote it by B dash, or you can write BC also, B complement. Complement means the elements which are there in universal set but not in set B. Then we'll say that they are complement of set B. So which are the elements which are not in B? 3 and 4. So these two elements are there in universal set but not present in set B. So our complement of set B will be 3, 4. Okay. So it is denoted by B dash or BC. It is defined as follows. Set of all x such that x belongs to universal set and x does not belongs to set B. Okay. That particular elements, the particular elements belongs to universal set, but they doesn't belong to the set B. That elements are known as complement of set B. Now here we have defined for set B, you can take any set, set A, set B, set C, set D, any element, any set you can take. For example, now I have a universal set here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my universal set. Set A is 2, 4, 6, 8, 10. So in set A, every element of set A, 2, 4, 6, 8, 10 is included universal set. So I can say set A is a subset of U. Now what is a complement of A? A complement. Complement of A means such element which are not in set A but present in set U. Means such elements which belongs to U but the elements does not belongs to A. So that is 1. 1 belongs to you but it is not present in A. 3, it belongs to you but not present in A. 5, it belongs to you but not present in A. 7 and 9. So these 5 elements are A complement and these 5 elements are sub A, set A. So I hope you understood the concept of complement of a set. Now let us learn some properties related to complement of a set. First property, complement of complement is the given set itself. Let us learn this with an example. Okay, we'll take the previous example only. Now this is my complement. Now we want complement of complement. Means this is my complement set, A complement. I want complement of this. Now when we take a complement of set, what is our definition? The elements which are not included in set A are complement of set A. Now we'll write the elements which are not in complement of set A are the elements of complement of set A. Means now in this set we will include those elements which are not in A complement. So 1 is in A complement, 2 is not in A complement. So I will include here 2. 3 is in A complement, but we want element which are not in A complement because we are taking complement of A complement. Then I will take 4. Similarly 6, 8 and 10. Now if you observe, this particular set is equal to set A. So we can say that set A is nothing but complement of complement. So if we take complement of particular set and we take again complement of that set, we will get the original set. So complement of a complement gives the set itself. We'll get the original set again. No elements are common in A and A complement. Right? As you can see in this example, in A we have 2, 4, 6, 8 and 10. In A complement we have 1, 3, 5, 7 and 9. Can you see any element common here? No, because A complement itself says that we have to take such elements which are not present in set A. So therefore no elements are common in A and A complement. A is a subset of universal set and A complement is also subset of universal set. As you can see in the example here, A is a subset of U because every element of A is present in universal set. Also, A complement is also subset of U because every element of A complement is also present in universal set. So this is our property. Complement of set universal set is empty set. Complement of empty set is universal set. Reverse of it. If I have no element here, what will be its complement? Universal set. All elements. If there are all elements, its complement will be no element. No elements complement will be all elements. Now let us move to the next topic, that is Venn diagram. Now this is another representation of a set. But this representation of set is in the form of diagram. Let us learn. Most of the relationship between sets can be represented by means of diagram, which are known as Venn diagrams. These diagrams consist of rectangles and closed curves, usually circles. The universal set is represented usually by rectangle and the subsets is represented by circles. In Venn diagram, the element of sets are written in their respective circles. Now this is a Venn diagram. So here you can see a rectangle. This rectangle is nothing but a universal set. So we represent a universal set with rectangle. So this is a universal set. And with a circle, we represent a subset. So this is our subset. Okay. Now from this diagram, what you can identify? Universal set means all the elements are present. Each and every element. So in universal set here, 1 is also included. 5 is also included. 9 is also included. Even 2, 4, 6, 10, 8, all are included. Because this is a universal set. So in this universal set, we have a subset A. This is a subset A. And in that subset, we have elements 2, 4, 6, 8, and 10. Now, the elements 1, 5, 9, 7, and 3, they are not included in subset A. Only these elements are included. So this is how we represent universal set and subset in Venn diagram. Now, after learning this theory, now we'll proceed to practice set 1.3, which is in your textbook, page number 11. Let us start solving the first question. So the question is, there are given 4 sets. A is equal to A, B, C, D, E. B is equal to C, D, E, F. C is equal to B, D. And D is equal to E. Then which of the following statements are true and which are false, that we have to tell. So let us write the sets first. So set A, it is equal to A, B, C, D, E. Set B is equal to C, D, E, F. Set C is equal to B and D. And set D is equal to A and E. So first question, C is a subset of B. Now they have told us C is a subset of B. It means that every element which is in set C must be present in set B. So how many elements are present in set C? B and D. And in set B, the elements are C, D, E, F. So if you observe, the element B from set C is not present in set B. So the statement is false. So we'll write, since each element or every element from set C is not present in set D, set B, therefore the statement is false. So this will be our answer. Let us move to the next question. Question number 2. A is a subset of D. It means that every element in set A must be present in set D. So elements present in set A are A, B, C, D, E, and elements present in set D are A and E. So if you observe, every element of set A is not present in D. So again, this statement is false. So you write the same reason which we have written above. So you just need to change the name of the set. Since each element from set A is not present in set D, therefore the statement is false. So this is a false statement. And reason you will write the same. Next. Question number 3. D is a subset of B. Now, this means that every element in set D must be present in set B. So in set D, we have 2 elements, A and E. In set B, we have 4 elements, C, D, E, F. So if you observe, the element A is not present in B. So again, this statement is false. A reason will be same. Since each element from set D is not present in set B, therefore the statement is false. D is a subset of A. It means that every element in D must be present in A. So in D, we have 2 elements, A and E. In set A, we have 5 elements, A, B, C, D, E. If you observe, both the elements in set D are present in set A. So this is a true statement. So D is a subset of A. So reason we will write, since every element of set D is present in set A, therefore the statement is true. Okay, this will be our reason. Next, question number 5. B is a subset of A. This means that every element of B must be present in A. So in B, we have 4 elements, C, D, E, F. And in A, we have 5 elements, A, B, C, D, E. If you observe, the element F which is present in B is not in A. So again, this statement will be a false statement. And the reason will be same. Since every element in set B is not present in set A, therefore the statement is false. C is a subset of A. This means that every element of C must be present in A. So in C, we have 2 elements, B and D. And in set A, we have 5 elements, A, B, C, D, E. So if you observe, both the elements from set C are present in set A. So this statement is a true statement. And the reason will be, since every element of set C is present in set A, therefore the statement is true. Let us move to the next question. Question number 2. Take the set of natural numbers from 1 to 20 as universal set and show set X and Y using Venn diagram. Okay, so we have 2 different questions. One is set X and one is set Y. And universal set is same for both the questions. So first we'll write the sets, all the 3 sets in roster form. And then we will draw the Venn diagram for it. So let us first write the universal set. So they have given us the universal set is a set of natural numbers from 1 to 20. From 1 to 20 means 1 and 20 will be included in that set. So U is equal to 1, 2, 3, 4, 5, 6, and so on up to 20. So this is our universal set. Now let us solve the first question. So the set of all X such that X belongs to natural number and X is greater than 7 and less than 15. So how many elements will be there in set X? So X is greater than 7. Greater than 7 means 8, 9, 10, 11, 12, 13, less than 15. So these elements will be my of set X. 8, 9, 10, 11, 12, 13 and 14. As X belongs to natural number, we'll take the counting numbers. And they have given one more thing, that it is greater than 7 and less than 15. So 7 and 15 will not be included as they have not mentioned less than equal to or greater than equal to. So this is my universal set and first set X. Now we have to show these both in a Venn diagram. So for Venn diagram, we will draw a rectangle for universal set and a circle for set X, which is a subset of universal set. Subset means you can see that every element in X is present in U. So X will be a subset of universal set. You can draw any shape, but the standard shape is rectangle and circle. So I am drawing here a universal set. First a rectangle. Then for the subset, I am drawing a circle. Okay. So this is how you have to draw a Venn diagram. Now we have to fill up the elements in the Venn diagram. We will first name the set. So this is my universal set and this is my set X. Now, how many elements are present in set X? So 8, 9, 10, 11, 12, 13, 14. These are my elements present in set X. So that elements I will mention inside the circle. So let us write. So element 8, 9, 10, 11, 12, 13, and 14. So these 7 elements are present inside the circle. 8, 9, 10, 11, 12, 13, and 14. Now rest of the elements which are included in universal set that are from 1 to 20, these I will mention in the rectangle. Now while mentioning all these 20 elements, already have mentioned 8 to 14 inside the circle. These elements will be also included in the universal set. So here I will only mention 1, 2, 3, 4, 5, 6, 7. Now 8 is already there inside the set X. So it is also included universal set. As universal set is the whole rectangle, you can see the whole area. So I will not mention 8, 9, 10, 11, 12, 13, 14 again. Directly will mention 15, 16, 17, 18, 19, and last 20. So this is how our Venn diagram will look. Let us move to the next question. Question number 2. So here we have to again write the roster form of the set Y. Question number 2, Y is equal to. So the set of all Y such that Y belongs to natural number. Y is a prime number from 1 to 20. Now we have to mention all the prime numbers which are from 1 to 20. Okay. So from 1 to 20, we have prime numbers. 2 is a prime number, 3, 5, 7, 11, 13, then 17, then 19. So these are our prime numbers from 1 to 20. Now we have to again draw a Venn diagram. So again, I will draw a rectangle for the universal set. Our universal set is same for both the question. So this is a rectangle and a circle for set Y. So this is our universal set and this is set Y. The elements inside the set. In set Y, we have elements 2, 3, 5, 7, 11, 13, 17, and 19. So these are the 8 elements inside the set Y. The rest of the elements we have to fill inside the rectangle. 1, 4, 6, 8, 9, 10, 11 is there, 12, 13 is there, 14, 15, 16, 18, and 20. So this is how our Venn diagram will look like. So I hope you understood how we have drawn the Venn diagram for both the questions. Now let us solve the third question. So here we have given a universal set and a set P. Then first question is given, show the sets U, P and P dash by Venn diagram. Then verify P dash, the whole dash is equal to P. Okay, so there are 2 questions given. They have also given the sets in the roster form. We need to draw a Venn diagram and we need to show these 3 sets. Universal set, set P and P complement. And then we have to verify whether complement of P complement is the original set or not. So let us draw the Venn diagram. Before that, you need to write the question set again. So here universal set is 1, 2, 3, 7, 8, 9, 10, 11, 12. And set P is 1, 3, 7, 10. Now we have to mention P complement also. So we'll write the set P complement also. What is complement of a set? Elements which are not there in set P, that we have to write. So 1, 2 is not there. You have to compare with universal set. So 1 is there in set P. So in P complement 1 will not come. 2 will come. Then 8, 9, 11, 12. So this will be our P complement. Such elements which are not present in P but present in universal set. So these are our three sets: universal set, set P, and P complement. Now we have to show this with Venn diagram. Okay. Now in Venn diagram, first we'll draw the universal set with a rectangle. So this is our universal set. And now we have two sets. One is set P and other is P complement. So here we have to draw two circles showing the two different sets. In previous question, we were having only one set, but now we have two sets. So this is our set P and this is P complement. Okay. Now let us name the sets and then we will fill the elements. So this is our universal set. This is set P and this is set P complement. First we'll fill the set P. So in set P we have 4 elements: 1, 3, 7 and 10. And in P complement we have 5 elements: 2, 8, 9, 11 and 12. So if you observe now, if you see the universal set, all the elements of universal set are present in set P and P dash respectively. So now we are not going to write any other element inside the rectangle. They are already included in the subsets. So this is our Venn diagram. Now we will verify the second question. Verify whether complement of P complement is equal to P. First we'll write set P complement. How many elements are there in P complement? 2, 8, 9, 11, 12. And our universal set is 1, 2, 3, 7, 8, 9, 10, 11, 12. Now we have to find P complement of complement. P complement of complement means those elements will come which are not included in P complement. So 1 is not included, 2 is there, 3 is not included, 7 is not included, 8 is there, 9 is there, 10 is not included, 11 is there, 12 is there. So these will be our set, elements 1, 3, 7 and 10. Now if you observe, thus P complement of complement is equal to P. See the set in set P complement of complement, we have 4 elements 1, 3, 7, 10, and the same elements are present in set P. So thus we can say that P complement of complement is equal to P, hence verified. The next question. So here we have a set given A is equal to 1, 3, 2, 7. Write any 3 subsets of A. So you can write any 3 subsets of A. What do you mean by subset? So elements present in that set must be present in set A. So we will write here some examples. So let's say set B is equal to 1, 3. So this will be a one set as each element from set B is present in set A. So we can write B is a subset of A. Next you can write C is equal to 2, 7. So also C is a subset of A. Then you can write D is equal to 1, 7. Again D will be a subset of A. You can also mention E is equal to null set. So E is a subset of A, as null set is subset of every set, right? So there are many examples you can frame: 1, 3, 1, 2, 1, 7, 3, 2, 3, 7. So we have asked only any three subsets. So this is your solution. Let us move to the question number 5th. Write the subset relation between the sets. P is a set of all residents in Pune. M is a set of all residents in Madhya Pradesh. I is a set of all residents in Indore. D is a set of all residents in India. H is the set of all residents in Maharashtra. So we need to write, they have given us 5 sets and we have to write the subset relation. And second question, they have asked which set can be the universal set. So let us write solve the first question. We have to write the subset relation for these 5 sets. Now, if you see, there are 5 places given: Pune, Madhya Pradesh, Indore, India, and Maharashtra. If you see in India, we have all the 4 places: Pune, Madhya Pradesh, Indore, and Maharashtra. So, all the 4 will be subset of India. Then, Pune is in Maharashtra, so Pune will be subset of Maharashtra. Indore is in Madhya Pradesh, so Indore will be subset of Madhya Pradesh. So, like this, we need to find the subset relationship. So first we'll start with Pune. We can write all residents of Pune. So all the people living in Pune are also residents of Maharashtra, right? If they're living in Pune, means they're living in Maharashtra. So all residents of Pune are the residents of Maharashtra. And also they are residents of India. And also residents of India. So the people living in Pune, they are residents of Maharashtra and also they are residents of India. So we can write Pune is a subset of Maharashtra and India. So Pune, they have given us the set P. So P is a subset of residents in Maharashtra, that is set H, and P is a subset of set B, which are residents living in India. So these are our 2 sets. Now same thing we will do with Indore. So how we can write for Indore? So all the residents of Indore are residents of Madhya Pradesh and also residents of India. So we can write set I is a subset of M and set I is also a subset of B. Okay. Now we'll compare the states. Madhya Pradesh, the people living in residing in Madhya Pradesh are the residents of India, and people also living in Maharashtra are the residents of India. So next subset relation will be all residents of Maharashtra and Madhya Pradesh are also residents of India. So therefore we can write H is a subset of B and M is also a subset of P. So we have got here 6 subset relation between the following sets. Now we have to tell which set can be the universal set for the above. Of course, the set of residents in India will be a universal set because all the residents in Pune, residents in Madhya Pradesh, residents in Indore and Maharashtra, all the people are living in India. So set B will be our universal set. So for question number 2, the answer you can write as set B can be the universal set for above sets. Let us move towards the next question. Question number 6. Which set of numbers could be the universal set for the sets given below? So we need to determine the universal set for the given sets. Question number 1. So there are 3 sets given. A set is multiples of 5, set B is multiples of 7, and set C is multiple of 12. Now we have to we have to determine the universal set. First, we'll write all the 3 sets in roster form. Okay, so let us write. Question number 1. First, set A. Set A is set of multiples of 5. Multiples of 5 means 5, 10, 15, 20, 25, and so on, up to infinity. Second set, set B. Multiples of 7. 7, 14, 21, 28, 35, and so on. And set C is multiples of 12. So 12, 24, 36, 48, 60, and so on. Okay, so these are our sets. So we have written the sets in a roster form. Now we need to find the universal set for all these sets. So these 3 sets are subsets. Now we have to find the universal set. What is a universal set? In that universal set, all the elements present in all the 3 sets should be included, right? So which universal set can we write? So we can write a natural set of natural number as a universal set of integers as a universal set of whole numbers as a universal set. If you write the set of natural numbers as a universal set for this, so all the natural numbers will be included. So every set A, B, and C will be our subset of that. So we can write here, we know that set of natural number is 1, 2, 3, 4, and up to infinity. Also, we can write another set, whole number 0, 1, 2, 3, 4, and so on. You can write integers -2, -1, 0, 1, 2, and so on. Right. So all these, any set you can take as a universal set. So for given sets A, B, and C, we can take set of natural numbers set of whole numbers and set of integers as the universal set. Okay, let us move to the next question. T is equal to set of integers which are multiples of 4. T is equal to set of all even square numbers. First, we'll write the sets in the roster form. Question number 2. T is equal to set of integers which are multiples of 4. Multiples of 4 means 4, 8, 16, 4, 8, 12, 16, 20, and so on. And set T, set of all even square numbers. It means that if you take square of 1, it is 1. Square of 2 is 4. Square of 3 is 9. Square of 4 is 16. So you have to take the even numbers, like 2 is an even number and square of 2 is 4. So here the element will be 4. 3 is an odd number, so we will not take square of 3. 4 is an even number. So again the square of 4 is 16. So next element will be 16. Similarly 6. After we write the square of 6, that is 36. Then 8. Square of 8 is 64. Then 10, 100, and so on up to infinity. So this will be our elements. So these are our 2 sets, set P and set T. Again, we can take the set of natural number as a universal set of whole number as a universal set of integers as a universal set. So you can copy the same thing here. The same thing you can write here. Okay. Let us move to the next question. Question number 7. Let all students of class is a universal set. Let set A be the students who secure 50% or more marks in maths. Then write the complement of set A. So what is our universal set here? Students of class. All the students of class is our universal set. So first we'll write a universal set. So here universal set is set of all students in class. Then set A, they have told us set A is set of students scoring 50% and above in maths. Set A is set of students scoring 50% and above in maths. They have asked, then write a complement of set A. Means we have to write A complement. A complement. What is complement? Complement means the set elements present in set A will not be included in the complement of A. Right? So in set, our set is that students scoring 50% and above. So A complement will be the remaining students who are not scoring 50% and above. So A complement becomes set of students scoring less than 50%. Set of students scoring less than 50% in maths. So this will be our A complement. So this is the end of our today's session. So today we learned about what is a subset, universal set, complement of a set, and Venn diagram. And we have solved the practice set 1.3 from the textbook. So I hope you found this video helpful and interesting. So do like, share, and subscribe our channel. Thank you.